Good afternoon, my dear kids. Again, one more time, welcome back. You know who is this? This is Mithun Raj, isn't it? Okay, of course, I am Mithun Raj, signing in from Cochin, Kerala, and welcome to the world of science. Okay, so what we want to do today? Okay, that is written on the screen, isn't it? That's today's class regarding second law of motion. Okay, otherwise we can say it explains the momentum, acceleration and all. Okay, M is mass, A is acceleration. Mass means measure of inertia. Acceleration you already studied. Okay, the rate of change of velocity. What is acceleration? Yes, of course, it is acceleration. Anyway, we studied in the last chapter what is acceleration, what is mass. But how to get this equation? Okay, how to get this equation? Here we have only momentum of an object. Understand? Momentum, what is momentum? I will explain. This equation actually we are deriving it. How we are deriving, we will see. So the second law of motion explained by, of course, it was explained by Sir Isaac Newton. Okay, the legend, the Sir Isaac Newton. Let's see. Here, another new term you want to study. Okay, another new term, and that is called as momentum. Okay, momentum. It is something related to motion. Understand? Something related to motion. Without motion, there is no momentum. Understand? Without motion, there will be zero momentum. Let's see. Momentum can be defined as mass in motion. Mass in motion. What will happen if you throw a small stone at a dog? A very small, tiny stone at a dog. A dog is sleeping in your front. If you are throwing a small stone at that dog, what will happen? Of course, maybe the dog even won't notice that you already have thrown a stone, isn't it? Because it is very small. But at the same time, if you are taking a big rock, you're taking a big brick and throwing at the dog. When it hits the dog, what will happen? Of course, the dog will cry and run away, isn't it? Okay, that's the momentum. Understand? That's the momentum. Mass in motion. So, something related to mass, something related to motion. Let's see. All object has mass. If something is existence or existed means it has a mass, isn't it? There is nothing in this world without mass. Anyway, in astrophysics, dark matter, zero matter, everything is there. That we don't want to study. That's a higher study for degree and post graduation. Not here. Engineering and all. Okay. Not here. Aerospace engineering, like that. Here, what we want to study? Everything in this world has mass. Not in the world, in the universe. If something is existed means it has mass. 100% it has mass. So if an object is moving, then it has momentum. It has its mass in motion. That the mass is moving, isn't it? If something is moving means the entire mass is moving. If a train is moving means the entire weight of that, mass of that train is moving. Why I am telling this? We will discuss that. The amount of momentum that an object has, it depends upon two variable things. Understand? Momentum is a property of a moving object which has mass. Understand? Okay, mass in motion is called as momentum. So, how to describe momentum? How much stuff is moving and how fast the stuff is moving. Two things. So, momentum is depending upon two things. If how much stuff, that means if the mass increases, momentum increases. And how much, with how much speed or how much fast it is moving. That means velocity increases, momentum increases. Understand? If we throw the stone very slowly, it will scare away the dog, but it won't hurt the dog. But if you are throwing it with full force, with high speed, isn't it? It is very difficult. Not very difficult. The dog will be, his day will be messed up, isn't it? The same thing happening when you are playing cricket. Which ball is easier to face? Anyway, I will give two option. What is Shoaib Akhtar? I don't know you know Shoaib Akhtar or not. A super fast bowler and a common slow bowler. Which ball is easy to face? Fast ball or slow ball? Slow ball, I am not telling about spin bowling. Okay, in your cricket, you already played a lots of cricket. Which ball is easy to hit six? Slow ball or fast ball? Maybe if you are an excellent cricketer, both balls are easy for you. Anyway, leave it. That was not a good option. Okay, now that momentum, another examples are there. We will study that. Anyway, actually, most of the batsmen they like to hit the fast ball. Okay, because they are extraordinary batsmen. Okay, sorry for that example. It's not a good example to tell the momentum. Okay, let's see. Momentum depends upon the variable mass and velocity. Mass, object will has mass. Motion means it has velocity. So momentum is what? Mass into velocity. Understand? Momentum is the mass into velocity. In terms of equation, the momentum of an object equal to mass of the object times the velocity of the object. That means what is momentum? Mass into velocity. And the symbol which we use in physics to represent momentum is P. P, okay, small letter P. That is the international sign for momentum. Understand? Not M. M means mass. P means momentum. Velocity, you already know V. Initial velocity U, final velocity V. M is mass, momentum is P. Thus, the above equation can be written as what? Let's see. Like this. Where is my animation slot coming? Oh my god, there is no animation for this. Oh, I forgot to put the animation. Okay, leave it. The unit of momentum would be mass units time velocity units. That means the standard metric unit of momentum is mass, SI unit is kilogram. Velocity SI unit is meter per second. So, the SI unit of momentum is kilogram meter per second, and of course it is a vector quantity. Any doubt about that? Momentum is a vector quantity because velocity is a vector quantity. Understand? Momentum 100% is vector quantity because mass kg is scalar quantity, meter is scalar quantity, second is scalar quantity, but velocity meter per second is a vector quantity because velocity has direction. So momentum also has direction. Understand? That's why it is a vector quantity, not scalar quantity. While the kilogram meter per second is the standard metric unit of momentum, there are a variety of other units that are acceptable throughout the conventional. Let's see, units of momentum include, examples include kilogram mile per hour, kilogram, kilometer per hour. Okay, that all things, let's leave it. But the standard unit is kilogram meter per second. Okay, that's the main thing you want to study. In each of the examples, a mass unit is multiplied by a velocity unit. Velocity has mile per hour. Another equation for velocity, kilometer per hour. But in common case, we are using this one. Okay, this is the standard unit. Okay, some places kilometer is being used, some places mile is used, some places centimeter is used. But in international level, the standard unit is always what? The standard unit is always meter and second. Understand? Not hour. Go. Let's see next. Momentum in everyday life. There's a lots of application of momentum in everyday life. See, have you seen karate? Karate players or karate masters, they are able to break bricks, isn't it? Lots of bricks they are able to break, lots of tiles they are able to break, isn't it? How they are able to break this one? Because they are creating enough momentum. Understand that speed of the hand. That means they are using that hand with high momentum. Understand that speed. And how much more speed you have, that much more momentum you can create. And that momentum is the reason for the bricks to break down. Understand? Simply, if you are slowly hitting the brick, will it break? If you are 10 feet tall and 500 kg in weight, very strong man, simply if you are touching it, will it break? No. But see, this is a very small man, but still he is generating enough momentum, enough speed. Okay, mass in motion. His hand is a mass. He is moving that hand in motion with high velocity. Understand? In this particular direction. See, If he is moving that in the upside direction, will this happen? It won't happen. That's why momentum has direction. Understand? So, karate player is able to break so many tiles because he strikes with his hand very very fast, producing an extreme large momentum. So, in this equation, you already know that momentum is directly proportional to mass and directly proportional to velocity. Okay, mass increases, momentum increases, velocity increases, momentum increases. But in one case only, when the object is at motion. If the object is at motion, mass will be there, but velocity will be 0. 0 into anything is 0, so momentum also is 0. Understand? To calculate or to momentum to happen in this world, the mass must be in motion. That is 100%. Okay, there is no other way. Come on. According to the second law, this is the definition for second law of motion. This is correct. The rate of change of momentum of body is directly proportional to the applied force and take place in the direction in which the force acts. So, the rate of change of momentum of a body means momentum divided by time, okay, is directly proportional to the applied force and takes place in the direction in which the force acts. So, see, this second thing, see, and takes place in the direction in which the force act means in which direction we are acting the force. If we are acting the force, see, in this case, he is acting the force here, so the momentum goes to this direction. Understand? So that is the explanation of the second law. The rate of change of momentum of a body. Understand? The rate of change of momentum means momentum divided by time to the applied force is directly proportional to the applied force. That means force is more, momentum is more. Understand? Force is directly proportional to the momentum. That is the second law of motion, and takes place in the direction in which the force acts. And that momentum, it applies in the direction in which the force acts. A simple example: if we punch somebody in the face, his face will be hurting, not his feet or leg, isn't it? Because the momentum is applied on the direction of his face. Leave it, no, don't hit anybody, okay? So the Northodox expresses as force is proportional to change in momentum divided by time. See, rate of change of momentum means change in momentum, final momentum minus initial momentum divided by time. Understand? See, this is another example for, anyway, have you seen this? In big offices, a particular, I forgot the name of this thing. Oh, okay, I'll give you notes regarding that. This is a very good example of momentum. If we play this side and leave it, means it will hit, and that all other 5 or 6 things won't move. The last one will move because the momentum is transferred into the last ball. Okay, let's leave it. We want this equation. Force is change in momentum by time taken. How to derive? Momentum, you already know what is momentum. What is momentum? Mass into velocity. You already know that. Okay, so F, what is this? F, no? Force is proportional to change in momentum. Change in momentum means, see, suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time, t by the application of constant force F through the time. We know that what is force? Force is change in momentum divided by time. See, we have initial and final momentum of the object. Okay, that is initial momentum P1, final momentum P2. Okay, initial velocity u, final velocity v, we already studied in that chapter. By this equation, if we substitute, F is proportional to final minus initial momentum, P2 minus P1, that is mv minus mu. Take m common outside. Understand? So F is proportional to m into v minus u by t. V minus u by t is what? V minus u by t is what? You studied in the last chapter. V minus u is equal to at, means V minus u by t is what? A, or acceleration, isn't it? Isn't that simple? You know how we got the derivation of F is equal to ma, this one. How you got? What is A? V minus u by t. From the momentum equation, momentum is what? Rate of change in momentum divided by time taken. Force is rate change in momentum. Change in momentum means final momentum minus initial momentum. P2 minus P1. P2 is mass into final velocity. P1 is mass into initial velocity. You substitute these values, we will get F is proportional to m initial final velocity minus mass into initial velocity. But in this case, mass will remain constant. Okay, how much the velocity increase, mass will be same. So we can take it as common. So F is equal to V minus u. The rate of change of momentum is what? Rate of change of momentum is velocity divided by time. Understand? That is V minus u by t. V minus u by t, we already know what is it. V minus u by t is acceleration, or A. So F is proportional to ma, and this k is a constant, proportionality constant. But how we are getting this equation F is equal to ma? Let's see here. Okay, here A is equal to V minus u by t in the acceleration, which is the rate of change of velocity. Okay, the quantity k is a constant proportionality. The SI unit of mass and acceleration are kg, and meter is second square. Okay, the unit of force is so chosen, the value of the constant k becomes 1. For example, if 1 Newton force, F is equal to kma. If 1 Newton force is applied to move 1 kg of mass and acceleration is 1 meter per second, then everything will be 1, isn't it? 1 is equal to 1 into 1. So k's value will become what? 1, isn't it? See, F is equal to 1. Mass is 1. Acceleration is also 1. If you multiply everything with 1, it will become what? F is 1. 1 equal to k into 1 into 1. 1 into 1, 1. 1 into k, k. So 1 is equal to k is equal to 1. Substitute that 1 in this k, means ma into k, ma into 1 will give us ma. So there is no change if we have k or not. So from this we are getting this equation F is equal to ma. Understand? Here one more time, this is the equation. I will show it in the board. Okay, then you will understand. Simply I am telling means you understand. That is the second law of motion. Some applications are there regarding second law of motion. Okay, second law of motion definition is this one. See, rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. That is the main definition for it. Okay, so my dear kids, that's it. That's the end of the class. I hope the first and second law was easy, isn't it? The third law is the easiest one. Very easy, third law. But before going to third law, there's a lots of application regarding these laws that we will study. Okay, so we will study that in next class. Till then, bye bye my dear kids. Mithun Raj signing off from this part of the world. Stay home, stay safe. Okay, bye bye and Jai Hind.